Our next speaker, next moderator, is from Auburn. He had got his bachelor's from aerospace engineering in Auburn, and he has worked a mess of programs: space station, constellation, commercial crew and cargo, and space launch systems. So he just can't keep a job, I guess. But he's got lots of experience there, and let me see, is Bobby Watkins here? No, okay, so we can say now we have the guy here who actually makes that office work. He's the Deputy Manager for the Human Exploration Development Operations Office at Marshall, and he's the Manager for Gateway Activities. We've heard lots of words about Gateway and what the Gateway means. Well, this next panel is going to explain the Gateway and the next steps for Gateway. So Joseph Pelfrey is moderator. Take it over.
Thank you, Alan. And thank you guys for joining us today. 50 years ago, this past Tuesday, Apollo 7 splashed down in the Gulf of Mexico. It was the first crewed mission for Apollo, and it was a major milestone to set the stage for the lunar landing that, of course, we'll celebrate next year, 50 years. So I find it interesting that between now and next summer, we'll be remembering 50 years ago milestones at each step of the way that got us to that lunar landing. And here today we're going to talk about the milestones, and you've heard some of the milestones we've already reached and the milestones coming forward to get us back to the moon. So NASA is going back to the moon and on to Mars in a sustainable way. The moon holds important information about our solar system, about our planet, how the formation of our planet and the history of our solar system, and holds resources for living and working and traveling further into space than what we've gone before. What we learn on the moon is essential for our journeys to further destinations. It's a proving ground for technical capabilities, for resource utilization, and continued learning about the effects of microgravity on the human physiology. In the same light, the International Space Station has been and continues to be a cornerstone of our exploration campaign and our integrated approach to deep space exploration. Continues to host research and technology demonstrations that are helping us enable what we're going to talk today and then what we're looking forward to in the future. So as you're aware, the administration has given us this direction through Space Policy Directive 1, which builds on the investments that we made on SLS and Orion and ground systems, the investments in our commercial partnerships and our international partnerships that are going to enable further exploration into the universe. So our panel today is going to focus on Gateway next steps and ties together the aspects of the current and future components of the agency's exploration campaign. So I want to introduce our panel, and then we've got a set of questions that I'm going to pose to our panel members to give them a chance to address some of these topics. So our first panelist is Jason Crusan, who's the Director of the Advanced Exploration Systems Division out of the Human Exploration and Operations Mission Directorate at NASA headquarters. Stephen Clarke is the Deputy Associate Administrator for Exploration in the Science Mission Directorate at NASA headquarters. Ginger Flores is the Gateway Habitat Element Manager here from Marshall Space Flight Center. And then to her left is Vanessa Wyche, who's the Deputy Center Director from Johnson Space Center. And I'm very thankful for their time and join us today to talk through this. And so we're going to do a format a little differently. I did give them questions ahead of time. I'm not that mean. But kind of sparked some conversation. We came up with some thought-provoking questions, and hopefully it'll lead to questions from you guys at the end that we'll allow for Q&A. So the first question goes to Mr. Crusan. Can you give us an update on Gateway and how it fits in the overall exploration campaign that we're working with the agency?
Thanks, Joseph. So, I'm lead hitter here, just kind of setting the stage. So I got a couple graphics that I'll show you. So as Joseph kind of elegantly described, I mean, Gateway fits in an overall ecosystem of activities, everything from our testing on ISS all the way through Gateway and actually even Lunar Landers and all that. So that's our entirety of our exploration campaign. And Gateway is a critical component of that overall activity. So if you look at our exploration campaign, a sequence of flights building up to the ability to get humans in and on the vicinity of the moon over the next decade here, and then actually deploy the Gateway, and then in parallel at the same time do a progressive growth of commercial landers, leading to eventual even human landers on the surface of the moon as well. So with that, if you can bring up my first charts, if I should be able to do it. I can do it myself. So if this is kind of the chart that we use to describe that sequence I was just talking to you about the whole series of efforts here, everything from commercial landers as soon as early as 2019. I think Steve and his team over in the science colleagues are getting really close to doing the selection on those commercial lander activities, leading then to a progressive and incremental growth of lander capabilities through 2022. And then we're planning a human descent module flight by 2024 of a full-scale human descent module. At the same time, while we're building up the Gateway activities that we have there. So a little bit about Gateway, the reason why we're here on this panel today. I just want to talk about a couple attributes of Gateway and a couple of what I call use cases as well of Gateway. We have it in an orbit. If you look on the right-hand side, there's a nominal 6-day orbit, the near retrolinear halo orbit. I don't want to concentrate so much on the orbit, though, because the Gateway has a propulsion system. We're in the middle of buying the power and propulsion element. That will enable us to actually move the Gateway from one orbit to another. And in fact, that's our intention to do that. We'll move it to different orbits to optimize for different science activities, be it this near retrolinear halo orbit, a distant retrograde orbit, an L2 racetrack orbit. We can do all those types of orbit maneuvers with the Gateway. And we do those primarily when the crew's not there. They're very mass efficient as far as the maneuvers that we have there. So we got some great animations and those types of things of those orbit maneuvers. Say if you wanted to, this is a South Pole optimized orbit, is our nominal orbit we have. But if you wanted to switch to a North Pole optimized orbit, you actually come out of the lunar orbit. You actually do a flyby of Earth, and you actually reinsert yourself back into a North Pole optimized orbit. So some really interesting trajectories out there on the order of 120 to 160 days. But you end up using anywhere from 50 kilograms to 80 kilograms of fuel for that entire maneuver to move the entire Gateway stack around. So really want the Gateway to be this hub of activity, so that it's critical infrastructure that if the orbit we're in today isn't the orbit we need for the science or the lander mission that we need to do, we'll move the Gateway's orbit to optimize for the specific mission in the case we have. It's infrastructure in that. That's this whole hub for activity. So as we do and progress towards human landings, if we need a slightly different orbit, we'll move the Gateway's orbit to optimize for that. And then eventually, as Joseph was noting, we also have the charge of going on to Mars. So as we build up Mars deep space transport type capabilities we want in the future, we'll also stage those out of Gateway, but the Gateway's orbit may need to be different in order to optimize for that Mars transit as well. So a little bit more about human access to and from the lunar surface. One of the big trades we've been working with on Gateway is how to enable reusable and refuelable landers or portions of the architecture to be reusable. So at the beginning, certain portions will be throwaway, potentially, but then we want as much of the architecture to be reusable as possible. And for reusability, you need a place, a dry dock location to put those pieces while they are refueled and then refurbished for the next flight. We want the Gateway to serve in that function. It is true that the delta V that it takes to get to Gateway in the near retrolinear halo orbit is slightly greater than going a direct mission to the surface of the moon. But if you look at the total delta V you need to optimize for that, you end up with a penalty of anywhere from about 2% to 6% penalty, and you trade that for reusability. So that's the trade we're doing. You've seen the trades that we've had today in launch vehicles going to a low Earth orbit, and the trade there is about 30% penalty or so in order to be able to return to the launch site with reusable first stages. The penalty in space for NRHO to actually optimize for reusable landers is somewhere on the order of less than 6% to get that reusability. So that's one of the key focuses. We want Gateway to be that refurbishment, that infrastructure to enable the reusability of things. We talk about international and U.S. Cargo capabilities. We optimize the orbit to obviously utilize the great capabilities and lift capabilities the U.S. has. Not everybody has that great capability, though. And we want our international partners to be able to also augment our logistics. So we optimize its orbit so that we can also use international launch vehicles to do logistics resupply, and also our U.S. commercial vendors to do logistics resupply. And in fact, on the U.S. side, just on Tuesday, released our first RFI for commercial logistics services for the Gateway. And we have an industry call actually this afternoon. So we're starting to progress towards our acquisition strategy to buy commercial logistics services for Gateway. We have a nominal 4-person crew. We intend that to be international. We want to start at 30-day missions and go up to 90-day missions. We're really just logistics limited is the limiting function. But we could actually go longer periods of time if that's what people desire or their mission class is there. We talk a lot about sample return, and I'll let Steve talk to more of the science applications of Gateway. He'll cover that next. But enabling that science is critical, science and the technology demos. The proving ground word that Joseph used, I look at proving ground as a proving ground for operations. When you start looking at these trajectories, when you move one orbit to another orbit, and you're flying back past Earth, you're reinserting through another orbit insertion maneuver that's all low energy trajectories. We are learning as a species now how to move large human spacecraft through the solar system on low energy trajectories in an optimal way and do those things like autonomous rendezvous and docking. The pure operations of a vehicle like this are going to teach us immense things over this period of time. And then we have an initial communications capability that'll be there from day one. It's like a geocommunications satellite for all these commercial landers that'll be coming into bear. And eventually we would expect an ecosystem of commercial relay type services to exist out there, both in the sector, commercial sector, and our international partners. So this is a little bit of a snapshot of where we're at in the Gateway. This is our latest configuration graphic we have. Our configurations change as a function of our normal design analysis cycles. We just are completing another one. The next design analysis cycle will likely maneuver some of these elements around the stack in order to move the center of gravity slightly to closer to the power propulsion element to enable things like these landers that we're talking about as well. So it's a continuous evolution as we learn both with us and what you'll hear from Ginger, our next step contractors as well here in the U.S. and then our international partners. So that's a little bit of a snapshot. So thanks, Joseph.
Great. Thank you, Jason. Stephen, can you discuss how the science community is embracing Gateway and the areas of focus for science utilization?
Okay, thank you, Joseph, and good. I guess it's still, good morning. I'm still on East Coast time. So the science community is very excited about having a new platform to do science. Earlier this year, a workshop was held in Denver, and various members of the science community, I mean the broad science community, was invited. And there was a couple-day discussion on what kind of science could be done from Gateway. And a lot of good proposals were read through and discussed, and we continue to work through those. And in fact, working closely with Jason and his folks on the planning for Gateway, the Science Mission Directorate has a voice in the planning as well. And so there are a lot of good science areas that are being looked at. I've worked with our science divisions continuously on kind of evolving what kind of requirements will be needed to be passed on to HEO to do the development of Gateway. And we are actually involved in the first major review of Gateway, which was the Formulation Sync review, where the Science Mission Directorate was asked to provide requests for actions to help evolve where do we want to put various instruments on the outside of Gateway, looking at from an optics standpoint, field of view, staying away from thrusters and so forth like that. So the science community is actually involved early in the development of Gateway, which is a great step forward. It's more specifically on science, looking at some of the areas like heliophysics. The science community there is looking at another platform to be able to collect data on solar wind. We have a lot of instrumentation on various NASA spacecraft and on NOAA spacecraft to collect data to help improve our forecasting for extreme space weather events that affects life here on Earth. But we're also looking outward now as we're going to expand human presence across the solar system. We need to have better forecast capability for our crews that are in transit, around the moon, on the surface, and when we move on to Mars as well. So the Gateway provides another platform to put those type of instruments to gain more knowledge of the solar wind, and actually how it actually interacts with not only the moon, but the magnetosphere and the ionosphere of the Earth and so forth, which will improve the forecasting capability. So it'll be a complement to the instruments that we have on various NASA and NOAA spacecraft now, both outside of Earth orbit and in low Earth orbit. Certainly from a planetary perspective, we're going to expand our science investigations of the lunar surface. We haven't landed on the far side, and so with Gateway in the NRHO orbit, we're going to be able to do more investigations on the far side of the moon from the orbit. But as we start getting more commercial landing capabilities, Jason mentioned the early commercial lunar payload services contract that we'll be awarding in December, where the commercial landing folks will be able to provide rides to us and multiple customers for instruments to basically land really anywhere we want to go on the moon. And so we're really excited about jump-starting that business case in the commercial industry there. So as we start populating the lunar surface, we're going to need to have a capability to uplink our data, not just direct to Earth, but so the Gateway, as Jason mentioned, is going to have early comm and data relay capability. That's going to be a big plus for the commercial landers and for the instruments that we're going to fly on those. Certainly, we'll look at more capability as that evolves. From an astrophysics standpoint, we're looking at, again, doing observations on the far side of the moon. Right now, it's radio quiet. That's where we need that capability, so we're going to have to work closely with the development of Gateway to determine how we can do that and maintain that radio quiet environment. So that's something we're working forward to, but I can tell you that NASA puts out these missions of opportunity from SMD, and Astrophysics is going to be releasing their next Explorer mission of opportunity in early spring of 2019. And we're already inserting language into that mission of opportunity to include Gateway as a platform to do science. So in alignment with the Gateway development, you can see where the Science Mission Directorate is going to start putting out calls that include Gateway as a platform. And certainly we've learned a lot by using the ISS as a platform for science, and we're incorporating those lessons learned into this new platform. So overall, the science community is excited about having another platform to do science, and it's going to be outside low Earth orbit, which provides unique vantage points to deploy small sats, CubeSats, and so forth like that.
Thank you, Stephen. Let's see. So the chart that Jason showed obviously had a very aggressive schedule. So Ginger, can you talk about our approach for streamlining the development process for Gateway?
All right, am I live? Thanks, Joseph. So over the past year or so, NASA's been working on efforts to streamline the Gateway module development. And one of those has been a focused effort centered around interoperability standards and standards to support human certification. We've collaborated with industry and our international partners to develop a set of interoperability standards with a goal of defining the interfaces and the environments that will allow industry and our international partners to develop systems or modules that are compatible aboard or with any other spacecraft, no matter who the developers or providers are. These standards will enable a broader collaboration and will apply across the larger exploration architecture, such as the Gateway and Lunar Landers. They're based on ISS standards, and we've incorporated additional lessons learned from experiences with the international community, and also leverage existing globally recognized standards. To date, we've prioritized 7 areas for our first cut at the standards in avionics, power, thermal, comm, robotics, ECLS, and rendezvous. And some specific examples of what I'm talking about with respect to these interfaces are things such as communication frequencies, voltage ranges, nominal internal pressures. So if you're interested in reviewing or commenting, these standards are on a very exciting public website located at internationaldeepspacestandards.com. And we have solicited comments that we're feeding into our updates currently. We're working to finalize those by the end of the year, but any additional comments will be folded into future updates. An example of how this is working real time is our approach for the power and propulsion element procurement. These standards have been identified as reference documents in the solicitation with a goal to minimize redesign of existing heritage architectures and rely on industry standards and processes. We'll accomplish certification by conducting an assessment of the industry standards and processes against a minimum set of NASA design and construction standards, interoperability standards, and safety requirements. And we've also asked industry to identify instances where a NASA requirement or standard could cause a departure from the existing design. So this may not sound that earth-shattering, but it is a real paradigm shift and is allowing more innovation and flexibility with our commercial base.
Thank you, Ginger. It's obvious that we're going to need that kind of innovation to be able to meet this schedule that we've laid out. Thank you very much. Vanessa, I had an image up where you, if you noticed, the first image had the moon, but you could see the ISS shadow crossing there. And I thought it was a great picture to think about having a gateway shadow on that moon here in a number of years. So, Vanessa, can you talk about how our experience from ISS is going to enable success on Gateway?
Great. Well, thank you, Joseph, first for inviting me to be here today. And thank you so much, the ability to share what's going on. For Gateway, Joseph asked, what experience did we have from ISS that we're going to take forward? And so when I think about ISS, first it's just the development, assembly using the space shuttle, and operation of ISS. Those are all things that are going to feed forward to Gateway. And when you think about the fact that we did that working with international partners, now we have commercial companies that are bringing logistics very similar to what we planned for Gateway. And so all of those things are going to feed forward, and we have experienced engineers and scientists that are prepared to take that on. So I wasn't sure how many in the audience were familiar with the capabilities of the International Space Station. So this video is it'll loop around. It just talks about this platform that Steve mentioned, where it has, everything from 3D printers, the ability to do material science, medical research on board. And so we'll be using this as a platform also as a test bed for exploration. So going from station to Gateway, right now on the ISS, we send about 1,000 commands a day. For Gateway, we want the crew to be able to be autonomous away from the ground control. So this is going to have us rely more on automation for both crew and also for robotics. Technology advancements, I'll talk a little bit more, but we're building a new exploration suit for Gateway. We're very excited about that. For commercialization, as I mentioned, we have cargo services today, and for Gateway, we're going to increase that capability. We're leveraging our international partners, potentially expanding those. And then for utilization, the intent is for us to have a more capable utilization, as the crew will not be spending as much time working on maintaining the laboratory. And then the important thing is for us to bring the relevance back home. So as we shared today, what we see from Space Station and how it supports our outreach here on Earth, we'll be doing that from the Gateway as well. And the International Space Station as a test bed. So as I mentioned, we can do everything from certain kinds of technology. Right now, we're looking at how do we miniaturize medical devices, our exercise systems. We have a lot of extensive research that we're doing on board. These are just some of the technologies that have already been flown, capabilities that we're looking at that will feed forward to exploration. Everything from new radiation monitors, DNA sensors, navigation, computers, and we're spending a lot of time trying to understand the human systems. And this is just a list. Don't intend for you to read it, but just to let you know that these are upcoming opportunities that we'll have coming forth on the International Space Station very shortly. And as I mentioned, we have a spacesuit that's in development. The spacesuit that we currently use was built in the late 70s, early 80s. And so we now have the capability to do some on-orbit testing. We have a rack experiment that will be up on board the space station, hopefully in the spring, that's going to look at thermal loop control. And then we have plans already to build a new exploration suit. And we'll test that on board the space station in the 2023 timeframe to be ready to support Gateway.
That's great, thank you. It's a great example how we're utilizing the assets we have now to further our future assets that we want to develop. Kind of following along with that, I'll send it back to you, Vanessa. In terms of human exploration, can you talk about how Gateway is going to build on the work that we've done in ISS in addressing knowledge gaps in crew and human health performance?
Okay. So many may not be familiar, but we actually have another program called the Human Research Program. And that program is looking at buying down risk for exploration. This is just some images of different on-orbit testing that's gone on. In the far corner over there, you have Scott Kelly giving himself a flu shot. We have a study where we look at what's going on with eye pressure. We also do ultrasounds on space, and then we are looking at fluid shift and trying to understand the impacts of that on an issue that we have with eye pressure, as well as being able to maybe combat that as a mitigation. So these are some of the human system risks that we're concerned about for exploration. And so the Human Health and Performance and Human Research Program have identified certain objectives that they test on board the ISS to actually buy down those risks. And the intent is as we buy down those risks using the ISS, we'll actually validate those in the Gateway in a more relevant environment. This is just an example of, on the space station, the exercise system is called the Advanced Resistive Exercise Device, which is the very large, it's about the size of something you would see in a gym. And this device on the other side is miniaturized, is 1/10 the size and mass, and it has the same capability. And so we're testing that out on board the space station today. But as we go forward, we're using what we've learned on the space station. We did a 1-year mission where we were able to do some studies. And so what we're going to do, as I said, we'll validate that on the Gateway, and then we'll do some follow-on demonstrations on ISS as we move forward.
Thank you, Vanessa. Obviously, the ISS has been a tremendous platform for science and utilization. But Stephen, can you talk about how Gateway is going to enable science different than ISS?
Thank you for the question. As I mentioned earlier, this is going to be a unique platform of itself in the NRHO orbit. Is going to provide vantage points that we have not had before on a repeating basis. With ISS, we're in low Earth orbit, and certainly that has played well into the Earth science research activities, and they're ongoing today. But from the NRHO standpoint, it opens up a whole new purview of vantage points to do observations and investigations. I mentioned the heliophysics instruments that we're looking at putting on there. Again, that's going to be a different vantage point than low Earth orbit, than at L1, and even the farther reaching spacecraft that we have operating today. So it's going to be a whole different set of data that we'll be able to use, the investigations, and the investigators will be able to do more research with, and most likely have more conclusions on better understanding the sun and how it works and how it interacts with all of the bodies within the solar system. That's one example. The fact that we have Gateway in place, and with the commercial landers that Jason talked about and I talked about, that's going to be an ongoing asset that I think the commercial folks will be wanting to use, in particular for the services that they're going to provide, not just for NASA, but for other customers as well. We're talking about lunar sample return. We had 6 successful Apollo landings, and we have a lot of samples that we've already opened, and researchers have done a lot of good work on it over the decades. We have some that have not been opened yet from Apollo 15, 16, and 17, but there is a limited number of samples. And so, and they were from a limited area on the surface of the moon. So we're certainly looking at doing sample return from various parts of the surface of the moon, far side, the poles, and so forth like that. Certainly we want to look at Gateway as a potential location to bring those samples so that then they could be brought back to Earth when the crew and Orion come back. And they'll be in well-preserved containers and brought back to the curation facility at JSC. So we're looking at that as a huge asset to be able to bring more lunar surface material back and to do research on that. And then I mentioned the planetary aspect of it too. We may be able to do some telerobotic work from the Gateway on the surface of the moon. And just the fact that we can also deploy small sats and CubeSats from that location certainly will be a big bonus to be able to do not just planetary science, but even potentially Earth science as well from, again, a different vantage point, looking back at the Earth and being able to do investigations. So, again, we see Gateway as another unique platform to be able to get more data, and I'd say rich data all across the science communities.
Great, thank you. So we've talked a little bit about how important partnerships are to make this happen. And under Jason's leadership at our AES, they started the Next Step program. And so I was going to ask Ginger to talk a little bit about how we're leveraging the Next Step work into the development of the Gateway.
Okay, thank you. So just a quick reminder on what we have been doing with the Next Step BAAs is related to habitation development specifically. And for you guys that aren't familiar, Next Step BAA is a NASA acronym which stands for Next Space Technologies for Exploration Partnerships, broad agency announcement. And so these partnerships are a model which have provided NASA significant flexibility in seeking private sector innovations. The original Next Step BAAs were issued back in October of 2014, where NASA requested proposals for concept studies and tech dev projects in 3 key areas: advanced propulsion, habitation, and small satellites. In the habitation area, NASA selected 7 proposals for habitation concept studies that the goal of defining the architecture or subsystems for deep space capabilities, and 3 advanced life support system concept studies. So most of the Next Step efforts require some level of corporate contribution, typically a 20% contribution towards the overall development cost or 10% for small businesses. And this model of public-private partnerships aids us with fostering the industrial base and commercial space sector. It also facilitates NASA's tech transfer into the commercial sector. This approach allows us to assess the maturity and alignment of commercial capabilities to our needs in the development phase. So following the success of the original Next Step BAAs, we issued Next Step 2 in March of 2016. This is an omnibus BAA. That's another word that we like to use as part of the government. This allows the agency to issue appendices to solicit studies, concepts, tech dev, prototypes, and actual spaceflight hardware development to demonstrate these capabilities both on ISS and on the ground. So for Next Step 2, we selected 6 companies to develop habitation ground prototypes or concept studies. And through these companies' human-in-the-loop testing, where current and former astronauts may also be participating, this begins in February with their ground prototypes and will be staggered. NASA will assess the overall form, fit, function, performance across a variety of these approaches, and those results will inform our next phase of our habitation process.
Okay, great. Thank you, Ginger. So another great example how we're going to leverage partnerships to make this happen. And I think we all understand how important that's going to be. So I'm going to throw it back to Jason one more time to talk a little bit about the overall exploration campaign and other aspects and how it's going to interact with Gateway.
So one of the other things I want to pull on actually with what Ginger described to you about public-private partnerships is the thing that we're approaching Gateway with is from the beginning is how do we create an ecosystem? How does the government fund some critical infrastructure? How does that infrastructure then enable lunar activity and eventual Mars activities for the NASA exploration needs that it has? But at the same time, how do we acquire it in such a way that we enable an ecosystem of activity to exist? So much like with the space station today, we're trying to transition International Space Station into a broader set of activities of LEO commercialization, LEO exploitation type of activities for commercial benefit and for a wider research community than just NASA. From Gateway, from the get-go, what we're doing is trying to broaden. We're working with our tried and true partners that we have today, expanding to new international partners. At the same time, working with our U.S. industry, so any U.S. contributions to the Gateway infrastructure and capabilities are provided in such a way that NASA's working that hand in hand with industry. We'll see, many of you guys from the industrial side here in the room, how do you want to utilize some of these capabilities for other activities that are not just meeting the NASA requirement, but maybe it's a business-to-business type of relationship. So how do we enable, and I'll give you an example. In the power propulsion element, that solicitation that's out there now, there are a set of unique NASA requirements along with the interoperability standards that Ginger pulled on. But in addition to there, we allow the industry to describe any other requirements that they may want to go do and what those objectives are. We actually don't take possession of the power propulsion element until after we take possession on orbit, after it's been utilized up to a year for whatever application industry wants to use it for. We've been careful not to say what our ideas of those applications are because we're not the ones that should be picking that. Industry should be the ones picking that and what those potential use cases are that they have for their own needs. So as we progress through, I mean, we're now put out the RFI related for logistics services. We're asking industry 6 kind of key questions there about how to do logistics services. How do they do launch and logistics services for LEO, and how do we extend that into deep space? Where do they need to go do that? What's the right way to buy it? So what's the right way? Is it modules and launch vehicles, or is it an integrated service? What is the diversity of launch vehicles? How does that drive some of the key decisions on how we go buy that? And very much we want to interact with industry and get that active feedback, and we'll find the kind of Venn diagram overlap of where the optimal way to go buy something is to enable that ecosystem to keep on expanding. The same thing happens with our international partners. We just had the International Astronautical Congress in Bremen. Lots of discussion of new entrants internationally from around the world. They want to be part of the exploration campaign. Not just Gateway, not just Landers, but they want to start moving into exploration activities as well. So there's definitely a surge out there. So we want to set up a framework to enable those new partners to be able to be there with us on Gateway or Lander activities, the whole campaign. So that's part of the big shift that we're going about that I didn't have a chance to touch on earlier, but we'll leave some time for questions too.
Absolutely, thank you. So I'd like to just hopefully recognize that this panel put them a lot of time into being here, and I appreciate them being. So let's give them a round of applause, please. So we definitely have time for questions.
We do. Any questions, including where those socks came from, Wicked?
Happy socks.
Clive Neal, University of Notre Dame. Couple of questions, actually. Jason and Steve, you talked about lots of science opportunities and partnerships. How are you're going to do reusable landers? Because the science workshop showed that Lunar Science was probably the least well served by Gateway in that configuration. You notice I put that in there, that proviso, because it's changed a bit. But reusable landers getting to the surface will be an enabling asset, and certainly incredibly useful both for science and exploration. But how are you going to refuel those landers if they're reusable? There was, in the configuration there, I didn't see any refueling capabilities. And if you do have a tank up there for cryogenics, then outgassing may play havoc with some of the optical instruments on the outside. So that trade is being worked or has been worked?
Yeah, so a little bit more about the architecture on reusable landers. We're still in the middle of analyzing those cases. Our fundamental architecture on reusability is portions of things like ascent stages, maybe some kind of in-space stage to move things around, can be reusable and refuelable. In our power propulsion element, we actually have refueling two ways. We have an aft-end commercial-defined refueling port, meaning it's open-ended to however the power propulsion.
Well, that's xenon, right?
It's xenon, and we believe it is hydrazine, but it's not defined actually in our procurement. Okay. Our models are based on that, but they could actually pick a different fuel source for there. So PPE can be refueled that way and also actually forward as well. It has a refueling through our NASA docking system. It's an international standard there as well. The elements, the actual elements that for landers, when they're docked on the gateway, we're not envisioning some large piping system and those types of things flowing through gateway through the habitable modules with fuel. That would introduce all kinds of interesting risks that we wouldn't want to do on the human spaceflight system. But rather, what we want to do is define commercial refueling interfaces on those reusable elements. And just like we're buying logistics services, we will buy commercial refueling services. And we are, for the gateway itself, we're buying eventually power propulsion element. It has a 15-year life defined as orbit maintenance and a couple large maneuvers. If we burn through the fuel faster than 15 years, we plan on refueling the power propulsion element. So we'll buy commercial refueling services for the gateway itself. So what we want to start doing is start shifting into an ecosystem of logistics and commercial refueling as a function of the total mass that you're launching. And that starts an ecosystem based on refueling that's existing in cislunar space. And I say that right now we'll launch it from Earth, but over time, if things pan out and the science is right, which hopefully you did that right, Clive, there should be a plethora of ability to fuel from the moon eventually. And this is critical, though. I mean, it's a critical point. I mean, you have to bake into your architecture an assumption of refueling, or you'll never be able to utilize things like ISRU. So what we're trying to do is choose an architecture both in Gateway's performance and the landers themselves, so that when ISRU comes at some point in time, we don't really care where the fuel comes from, and it's up to industry to supply it to us. So.
Hi, Jeff Faust, Space News. Probably for Jason. As the Gateway design evolves, at what point do you feel like you'll be able to start making decisions on who will provide which elements of the Gateway, whether they're international partners or commercial partners or through NASA contracting?
Yeah, so for the U.S. side, we know absolutely we will provide a power propulsion element as a contribution. We're in the middle of the procurement for that. We know we will supply at least some portion over the overall logistics as well. And we will have a domestic habitat that will be supplied from the U.S. Industry as well. That's kind of our minimum set. What we're doing now is working with our international partners of where they would like to contribute. And you see in our architecture configurations some ideas of where they'd like to contribute, be it a robotic arm, what they call it a spree, which adds additional fueling and refueling capabilities, along with a scientific airlock, additional habitable volume in the form of international hab. Over the next coming year, so we've had a series of engagements with the international partners. Those are ongoing. We have planned what we call multilateral control coordination board meetings this fall. And at that meeting this fall, we'll get a general sense of where our international partners would like to contribute. And then they will go through their own budget processes, and we'll start the international agreement negotiation phases of things. And then the actual commitments come at a phase of when they get their budget capabilities and their formal, and we conclude those formal agreement negotiations. But over basically the next 14 months timeframe is when some of that will be firmed up. But getting back to Ginger's comment about we want an open architecture. So we want to enable newcomers and new contributions from other additional international partners. So we'll see how that evolves over time, and we want to keep this idea of an open architecture. It will be the gateway itself will be a finite performance capability envelope at some point. It can't be over X mass. It won't be able to, we'll want to be able to make sure we can control the stack and those types of things. So there is a finite kind of overall performance for it, but we'll see how the actual individual contributions shake out over the next 14 months or so.
If you don't mind, I just wanted to go back to Clive's question, because he did kind of look at both of us about how lunar science has been somewhat underserved. Certainly Gateway is going to be an enabler, right, for us to do more lunar science. But what I don't want folks to forget the point of what we're doing with the commercial lunar payload services. That is going to start the process of us doing more lunar science early, right? And when Gateway comes online, we're going to be able to use that as well together. And if you look at the slide in front of you too, we're also looking at mid-size robotic lander capability as well. The Commercial Lunar Payload Services contract, which is a 10-year contract, we're going to have on-ramps to that contract, and that will allow industry to propose additional capability as they evolve and develop that capability to come onto the contract, so that then we can issue task orders asking for whatever increased capability they have. So you can see we're starting with the small commercial landers. We're working closely with Jason and his folks on the Gateway enabling science. And then we're also looking at a mid-size lander capability as well. And as HEO develops the next human lander, we're certainly going to be working closely with them on will there be accommodations to take any science instruments along with them, and on those reusable landers as well. So all of this really fits well together. So I just want to make sure that I had addressed that question too.
Hi, Bhavya Lal from the Science and Technology Policy Institute. Just kind of following up on that same question for both Jason and Steve. What do you see as the cadence of SLS and commercial launches in the 2020s, like numbers, proportions?
So, I mean, right now we are planning the nominal kind of one flight per year for SLS and utilizing that to deploy in a co-manifested fashion the majority of the Gateway capabilities. For the lander type activities and the commercial logistics services and refueling services, a lot of that actually is reliant on commercial launch services as well, with some elements also being related to landers, still doing some co-manifesting on SLS as well. So it's really a mixed fleet. The specific numbers of launches, I don't know those off the top of my head, but we're looking at a really basically utilizing SLS for its incredible ability to lift crew and cargo at the same time and optimize that period of time, utilizing the crew to help enable things like delivering Gateway elements, having the crew there to do the outfitting and those types of things in close proximity. And then at the same time, then leveraging commercial launch vehicles to deploy things like logistics services, refueling services, and those types of things. So it's really a mixed fleet option, I guess.
Thanks, Alan's got one.
And for the commercial lunar payload services, the requirement of that contract is for the commercial lander companies to coordinate the ride, the launch vehicle. So all of those will be commercial launch services. And so when I said NASA and other customers will buy a ride, those companies will be arranging the rocket contracts with the landing companies. And so I expect early on, the cadence will pick up as the business increases. So, certainly don't have any numbers off the top of my head either, but I think the commercial launch industry is going to be busy.
Dell Thomas, University of Alabama, Huntsville. So that looks sort of like a mini ISS in a really cool orbit, but that orbit is outside the Van Allen belts. What provisions are y'all making to protect the crew from the deep space environment over that long duration?
So, as Jason mentioned, the durations are going to be 30, 60, building up to 90 days. And so that's what we're using currently, some of the research we're doing on board the space station, looking at either, wearables as protection. Also, there's pharmacology as protection, as well as potential, shielding for the vehicle itself. So those are things that we are testing out on the space station. Thank you.
And I'll just add, I mean, Orion has storm shelter abilities built into it. So whenever the crew's there, Orion will be there. So they have that inherent capability that Orion provides for storm shelters. And then the HABs themselves, being that they are HABs, they'll have additional structures and volumes and stowage and everything else that will likely provide, if not equal, but better storm shelter abilities as Orion has. But Orion's there, so.
Hi, this is Lenny from the University of Illinois. I had a question about you guys' vision on the Gateway's role on establishing a semi-permanent lunar infrastructure, potentially for future ISRU development, and what you guys see for the Gateway's future, should it be constructed after its proposed 15-year lifespan.
So, I mean, I think we're trying to figure out what is the role for governments and what is the role for industry. And then a lot of this is dependent on what are the other use cases beyond government exploration programs. So a lot of this is there's a lot of trial balloons in order to figure out what are the business models that can actually work. We're doing a lot of those in low Earth orbit today, and there are business opportunities there, but they're still in their early stages. Deep space business opportunities are even further out because they'll be relying on government funding at the beginning. It is one of the things we're trying to do is acquire Gateway, the things that we do buy for Gateway as a government, buying them in such a way that they can be utilized by others for other non-NASA mission purposes, be it communications services, be it the commercial logistics services. We're trying to buy as many components as we can in a way to enable industry to exploit those capabilities for some other customer. And so that's one of the big key things there. On the 15-year life, I'll just touch on that for a second. It's not that we envision Gateway to only be there for 15 years. To be honest, this is a statistics engineering game we're playing. Everybody certifies for 15 years in many commercial systems. You go past certification for 15 years, and you start playing statistical games that you pay dearly for. So that last extra certification that you pay for beyond 15 years, you pay a lot of cost for that certification. And so what we're doing is certifying things for 15 years. We fully expect to do on-orbit service life extension, much like we're doing with the International Space Station today, to actually look at the operational data and the actual in-orbit performance to actually extend Gateway's lifetime beyond that period. But then at the same time, we built it in a modular fashion that if we wanted to change out a major component, say the power propulsion element, we could change out the power propulsion element on some future mission as well, because it's a modular design.
Hi there, Daryl Shook from Honeywell. Thanks for the discussion. I've heard you say that the Gateway could be a test bed for hardware, but how do you work with somewhat of the uncertainty of ISS life extension? Are you making an assumption that the official answer is it's 2025, but we all know that they're going to likely extend that past that? How are you handling that kind of uncertainty when it comes to the role of Gateway as a test bed versus ISS as a test bed in the future for a longer period?
So just to be clear, I mean, ISS is our primary test bed for exploration technology. And that's where we're going to do the primary portion of testing. And as ISS and things that follow afterwards, we will still use low Earth orbit for primary testing location. Gateway, there will be unique aspects of the environment, as Steve was talking about from a science perspective. There are unique aspects from an engineering perspective that we'd like to do some of that testing and validation. I don't know, Vanessa, if you wanted to add to that, because you were talking about the validation approach too.
No, I was just going to mention that certainly, so for example, for the exploration suit, we're making sure that we are planning all of our tests so that we can validate prior to the planned in for ISS. But as Jason mentioned, we do expect to continue to do testing in LEO, whether it be on that space station or another LEO platform.
Yeah, Al Tadros from SSL in Palo Alto, California. This question is for Jason and Steve. In the early years of the Gateway, science and, of course, Orion are going to be using Gateway. Can you describe how the science will be first deployed there? What will it use? What do you envision it'll use initially, and who will kind of make the architectural decisions of what modules are attached and so forth in the early years?
Yeah, so in the early phase, we have a payload, we have an interoperability standard for payload attachments. So we have a minimum set of payload attachment locations that are required in the power propulsion element. They're called the SARI interface and LGPFs for the robotic arm kind of walk-on, walk-off interfaces. Those are set as minimum, and we'll see how many payload attachment locations we get on the power propulsion element. Today, the very first pressurized elements that go up are an Esprit and our utilization module, which will give us our first kind of pressurized area, access to the science airlock. And then on the very first logistics flight is where we would expect significant science payloads to come up there. But we would see payloads coming up on the very first very first pressurized flight as well. As far as prioritization and those types of things, that's still, I don't know if Steve has thoughts on it.
Well, as I mentioned, we're in the Science Mission Directorate, we're starting in spring to start putting the gateway into our calls for missions of opportunity. And as that's moving along, we're working closely with HEO on how gateway develops and where the individual modules will be. Certainly a robotic arm is going to be key, I think, to placing the instruments on the outside of the various modules. As we do with Space Station, sometimes we get involved with the development of the pointing platforms that are needed because it's a unique interface, right? We're given a basic interface on station on the ELCs, for instance, but if we need some unique pointing characteristics, then we'll provide the pointing platform that'll be going on there. So the addition of the arm is going to be key. I think we'll probably see an increase in instruments being installed on the outside when that arm is delivered. But as Gateway evolves and the design starts to become more firm and then gets locked down, we'll have a better idea of where those science instruments will be. We're working early on to help kind of influence that, but we have to look at it, for instance, when Orion is docked, we have to look at thruster impingement, field of view with the solar arrays, right, on Orion. We have to look at, is it better to be closer towards the power propulsion end? Can we be in the center? So, we'll be looking at all of that as the gateway architecture gets locked down.
All right, that looks like the end of time for our questions. Panel, we'd like to thank you very much for speaking to us. Let's give them a hand, please.